All right, we'll go ahead and get started with our 3.1 and 3.2, our second day with linear systems, but we're adding in some applications. So we're doing some word problems today. Exciting. All right, so for each one, we are going to solve each word problem. All right, I want you to practice because we're going to have two unknowns and two variables each problem. So we'll practice identifying the variables. No, that's not right. Identify the variables. Write the system of equations. And solve. So you'll be able to choose elimination or substitution. It'll be up to you. But here's our first problem. So the concession stand is selling hot dogs and hamburgers at halftime. They sold a total of 78 hot dogs and hamburgers. Oops. And brought in $105.50. All right, so here's the question that we need to figure out. How many of each item did they sell if hamburgers sold for $1.50 and hot dogs for $1.25? Whew, that's our problem. Love writing? All right. So, first thing we want to figure out is our variables. There's two things that we don't know. We don't know how many of each item they sold. All right, what are our two items? Hot dogs and hamburgers. So what would you like to use to represent hot dogs and hamburgers as a variable? We could use H, but what would H represent? Hamburgers. So I'm going to be specific and say the number of hamburgers and not a hashtag hamburgers, the number of hamburgers. But then what would I use to represent hot dogs? That sounds good. D for the number of hot dogs. All right, I like to use letters that would kind of match with what we're talking about. It's helpful when we get done and when I solve for D and I know that that was representing hot dogs, and it just kind of makes sense when I'm finished. All right, so each problem, I'm going to have 2 unknowns or 2 variables. So if I have 2 variables, that means I must set up 2 equations, otherwise I can't solve it. All right, so I need to look back in the problem and figure out how I'm going to create 2 equations with the information they gave me. All right, so first information, they said they sold a total of 78 hot dogs and hamburgers. And you think of an equation that would go with the amount of hamburgers and the amount of hot dogs and a total of 78. H plus D must equal 78. Okay? All right, now we've got a little bit more information remaining. They made $105.50. We also got $1.50 for every hamburger and $1.25 for every hot dog. Can you see a second equation that would come out of that remaining information? Yep. Yes, so I've got, it costs $1.50 for every hamburger plus $1.25 for every hot dog they sell would give us the total they made at those concessions, if that's all they were selling or were paying attention to. All right, so once I have my 2 equations with my 2 variables set up, now I'm choosing either elimination or substitution to solve. All right, so it's up to you when you set up these problems what you want to use. Both would probably be equally easy or difficult, whatever your opinion is on that. So I could, if I did elimination, I'd have to multiply the top equation by some decimals. So some students don't like that. It would also be pretty simple to get either H or D by itself to do substitution. So we got that going for us. Any requests? Let's do substitution. All right, I'm going to go ahead and solve for H. So I'll subtract D to the other side. All right, so I got H equals 78 minus D. So then I will replace the H in my second equation with 78 minus D. So 150 times 78 minus D plus 125 D equals $105.50. One thing I like once we start doing this with word problems and they actually represent something, sometimes it starts to make more sense as to why substitution even makes any sense, right? So we know that this is representing the amount of hamburgers, and the only way I could figure out the amount of hamburgers is if I take that 78 and I take away how many hot dogs there would be. All right, so that whole algebraic part is now kind of making sense as to why that works. All right, sometimes. All right, so we'll go ahead and distribute. So $1.50 times 78 would be 117 minus 150D plus 125D equals 105.50. All right, let's combine some like terms. So if I combine negative 1.5 plus 1.25, that'd be negative 0.25D. And let's go ahead and move over the 117 to the other side. And I get negative 11.5. All right, so something that's also nice with word problems is, right now I've got 2 negatives going on, but if I divide both sides by a negative 0.25, it'll come out to be positive. But if I get something that was negative, that wouldn't make any sense, and that clues me in that I have the wrong answer. All right, so that part is nice. All right, but this will turn out nice, so I get 46 for D. It also wouldn't make sense in this case if I got decimals, right? They're not going to sell part of a hot dog to a person, okay? It's just not what they're going to do. All right, some cases doesn't make sense to have decimals, yes, but not in this situation. So it does give you a good idea if you're right or wrong. versus when we're just working through problems for fun. With substitution and elimination, you get messy fraction answers and you have no idea if that seems like that would be correct because all it is a point on a graph. This has more of a point to that. So I like that. All right, so D was for 46 hot dogs. So pay attention in your problem when they leave you the blanks for write down how many hot dogs. Maybe that wasn't the first thing you had. Maybe it asked for hamburgers first. All right, don't just throw in 46 because it's the first answer you got. Make sure you pay attention. All right, so I take 78 minus 46, and then I've got 32 hamburgers for my answer. Okay. All right, we're going to practice 2 more examples for this lesson. So get ready to write down another word problem. Second example. So Mr. Doyle bought 2 pounds of cheddar cheese. And 3 pounds of chicken loaf. He paid $26.35 for his cheese and chicken loaf. Mrs. Doyle paid $18.35 for 1.5 pounds of cheese and 2 pounds of chicken loaf. All right, so here's our question, what we're trying to figure out in this situation. What was the price per pound of each item? All right, we will find out after lunch. Stay tuned. Okay. So we need to set up our 2 variables. Perfect. All right, so the question is asking what was the price per pound of each item? So we have 2 different items. We have the cheddar cheese and we have the chicken loaf. All right, so I need to come up with 2 variables to represent each of those items. Do you have a letter you'd like to use? So convenient, everything starts with the same letters. C. Perfect. C will represent which one? Oh, excellent. And this would be pounds, or what was the price per pound? So it's the price per pound of cheddar cheese. All right, what do you want to use for a chicken loaf? L. Make sure if you use an L, either use capital L or a cursive L. All right, don't write L like this. That'll look like a 1, okay? I'm gonna use cursive L because that's more common in math. All right, so this would be price per pound for chicken loaf. All right, so now we'll go ahead and we'll set up our two equations with our two variables here. So I take a look back through my information. I've got Mr. Doyle who bought 2 pounds of cheddar cheese and 3 pounds of chicken loaf, and he spent $26.35. All right, so if there's 2 pounds of the cheddar cheese, C, plus he bought 3 pounds of the chicken loaf, L, to give a grand total of $26.35. Okay. So then my second equation would come from Mrs. Doyle. She spent $18.35 for 1.5 pounds of cheese plus 2 pounds of the chicken loaf. All right, once we have our two equations with our two variables, we can go ahead and solve with either elimination or substitution. So up to you. This one to me is a little bit more challenging to get a variable by itself. It might get a little bit messy. So my preference for this one would be elimination. Doesn't matter which one we're trying to eliminate. I probably would multiply the top equation by 2 and the bottom equation by -3 is my instinct. So I'm multiplying each equation by something different. I'm doing that to eliminate the L's because I'm going to get a -6L, or sorry, a +6L on top and a -6L on the bottom. And then when I add them together, they would cancel out. So that is my instinct to solve this problem. So let's write that out. So I've got up on top 4C plus 6L would equal 5270. The bottom equation, I'd have -4.5C minus 6L, and 18.35 times -3 is -55.05. Then I'll go ahead and add those equations vertically. On the left, I get -0.5C. My 6 L's here would eliminate or cancel. And then combine on the right, I'd have -2.35. Divide both sides by -0.5. Oops, that would be wrong. All right, so it should come out positive. I'm dividing a negative and a negative, so that should make sense. So C would equal 4.7. All right, in the last problem we talked about decimals wouldn't make sense. Do decimals make sense in this problem? Yes, we are finding the price per pound. So this is representing $4.70 per pound for that cheese. Okay, so I got to go ahead and plug that one back in. Maybe a little more difficult to do that one in your head. It doesn't matter which one of those equations up top I would plug it back into. Let's go ahead with the top equation and plug it in. So I've got 2. I'm replacing that C with my $4.70 plus 3L must equal 26.35. So 2 times 4.7 be 9.4 plus 3L equals $26.35. Take away your 9.4. Some of this can be done in your head or on your calculator, but here's what I would be doing. And then I get 16.95, divide both sides by 3. So my L, or my chicken loaf, would be $5.65 per pound. So make sure you pay attention to what we set our variables up from the beginning. I like to be specific. and say what it is, so that when I just put cheddar cheese up there or chicken loaf and I get 4.7, I know that that actually means a price. Okay. We're going to look at one more type of word problem here. You'll see one like this in your homework. And I usually get lots of questions on these types because they lots of percentages and it throws kids off. So let's look at one of these and then we will be done. So a scientist wants to make 6 milliliters of 30% sulfuric acid The solution is to be made from a combination of a 20% sulfuric acid solution and a 50% sulfuric acid solution. Here's our question. How many milliliters of each solution must be combined to make the 30% solution? There's our problem. Students a lot of times get overwhelmed by this because they see all these percentages and they just kind of get lost and confused. So let's just start from the beginning. Let's create those two variables. I wrote it so long, can barely see the bottom of my screen. All right, so we don't know how many milliliters of each type of solution. All right, so I don't know how many milliliters from, these are the different solutions, the 20% and the 50%. All right, the 30% is of the whole thing. Okay, so I don't know if you just want to use X and Y for this one, maybe. Everything is percent solution sulfuric acid, so we'll just keep them pretty general. All right, so we would need the amount of milliliters at the 20%, and we need the amount of milliliters at the 50%. Okay. So those are the things that we don't know. When we go back to the beginning, I know that there are 6 milliliters altogether of this grand solution. So that's my two variables, right? The amount of milliliters of one plus the amount of milliliters of the other would give me my 6 milliliters. Okay. The next one has to do with all of the percentages. All right, so if I have 20% of my X variable, remember as a percent that would be or as a decimal, that would be 0.2, because 20% would be 20 out of 100, plus 0.5 Y. Maybe I should do a 0 so you can see it better. All right, that would be 50% of the amount of milliliters I have at that 50% solution. Now, if you do equal 6, you will get a no solution. All right, it won't make sense because I can't add the same thing, the x and the y on top to get 6, and then add part of them to get 6. All right, so that's usually a common error because I need 30% of this solution. That's what that 30% comes from here and in that final question. All right, so I need to figure out 30% of my 6 milliliters, and that will be the parts that I'm missing in that second equation. This will be a very similar setup to one in your homework. All right, so from here, once again, elimination or substitution is up to you. We can multiply by some decimals on top. If that's easier, we can get x or y by itself up on top. If that's easier, ultimately your choice. I might go ahead and actually multiply by decimals this time. And I think I want to multiply it by negative 0.5. Kind of an easy one maybe to do in your head is just cut them in half. So I've got negative 0.5x plus negative 0.5y would equal negative 3. All right, keep the bottom one the same. So 0.2x plus 0.5y equals 6 times 0.3 would be 1.8. Now we'll be able to eliminate the y's. We'll go ahead and add those together. So when I add these together, it'd be negative 0.3x. These would eliminate, equals negative 1.2. Divide both sides by negative 0.3. And then x would be 4. So that means there are 4 milliliters needed at the 20% solution. And if altogether we needed 6 milliliters, that means there would be 2 milliliters at the 50% solution. All right. Your homework, you do not have very many problems. It says there's a worksheet. There is no worksheet. All right, so you're welcome. Just the couple problems you have in Math Excel. Good luck. Have a great time.